So what we're going to do now is we're going to use what we've learned about the trends on the periodic table and the factors that cause them to rank elements in terms of the different properties that we looked at. And more importantly, we're going to justify that ranking using the terminology that we learned. So here we're going to rank these three elements in terms of their first ionization energy. Now, as we talked about, the first thing that we need to do is we need to define our property that we're looking at, and then we need to link it to our force of attraction. So here we're identifying our ionization energy as the energy required to remove an electron. And then we're also saying the greater the force of attraction, the more energy required to remove an electron. Okay, so we've done our first two steps with addressing. Now what we need to do is we state what our force of attraction is due to. It's due to our effective nuclear charge or our distance. And now we're going to tie it to our properties. So we know as our ENC, or effective nuclear charge, increases, force of attraction increases, meaning higher ENC, higher energy required to remove an electron. As distance increases, the force of attraction decreases. So the higher the distance, the lower force of attraction, the easier it is to remove an electron. So after we've identified what our property is, we've linked our property to force of attraction, we've stated what our force of attraction is due to, then we start looking at pairs of elements. We start comparing pairs or groups of them. So in this case, I look at my lithium and my potassium. And we know that because they're both in the same group, their ENC value is the same. As we've learned in class, ENC value is the same as group number. So therefore, since they're both in group 1, they have an ENC value of 1. But what we do know is that they have different distances to their valence energy level. Okay? We talked about how in class each period basically represents a different energy level. So therefore, lithium, being in the second period, has a distance of approximately 2 to its valence electrons, whereas potassium, we could assign it a distance of 4 since it's in the fourth period. So since potassium's valence energy level is further from the nucleus than lithium's, we know that potassium's electrons in the valence energy level will feel a lower force of attraction than the electrons in the valence energy level of lithium. As a result, due to potassium's electrons feeling a lower force of attraction, it's easier to remove an electron from potassium. Because lithium feels a greater force of attraction due to its smaller distance, it will require more energy to remove an electron. So this allows us to conclude that lithium will have a greater first ionization energy than potassium. Okay, so after we're done comparing our first two, then we can compare our second two. And so we compared two that are in the same group. And now what we'll do is we'll compare two that are in the same period. We don't want to change both group and period when we're doing our comparisons. So I would not compare potassium with sodium because they're in different groups and in different periods. I want to pick where they're in the same group or they're in the same period when I do my comparisons. Because they're both in the same period of the periodic table, we know that they're going to have the same distance, or d, generally to their valence electrons, because they're both in the second period. We can say that they both have electrons in a second valence energy level. So this gives them the same d. Also, they both have the same number of core electrons. Because they're in the second period, they were filling up our second energy level. We know that the first energy level is core, and for both of them it holds 2 electrons. So they each have 2 core electrons. What this means is that any difference in the attraction that the electrons feel to the nucleus between nitrogen and lithium will be due to the effective nuclear charge. Because d is the same and number of core electrons are the same, as I increase my number of protons in the nucleus, it will cause my ENC to go up. And since ENC is greater for nitrogen than for lithium, that means that I'm going to have a greater force of attraction for nitrogen than I will for lithium. This greater force of attraction for nitrogen means that it's going to require more energy to remove an electron from nitrogen than it will from lithium. So therefore, nitrogen will have a greater first ionization. So after we're done doing our comparisons in terms of our groups and our periods, then I can rank them. And so in this case, my order from lowest first ionization to highest would be potassium is less than lithium, which is less than nitrogen.